Good morning everyone. Welcome to Gate Academy Global. So just confirm me audio and video both are clear or not. So just confirm me everything is perfect so that we can continue our today's session. Okay. Good morning everyone. Just confirm me everything is perfect or not. Audio, video, everything is clear or not. Okay. So if you can see in last session we have discussed so many number of questions for especially finite state machine as well as state transition diagram. So I hope now easily you can handle any kind of question, okay. Now today I am going to discuss another good question from sequential circuit also, okay. So first question I am going to start, and most of the question I will take from flip flop as well as counters, okay. Everything is perfect, okay. Now so just I am going to take first question in today's class, and you have to think about that question. First, and that is very good and very basic problem, okay. So now first question I am going to take, okay. So now here you can see, okay, first question, okay, which of the following input sequence. So the question is, just note down which of the following input sequence, which of the following input sequence for a cross coupled RS flip flop, for a cross coupled RS flip flop, so here mention cross coupled RS flip flop, realized with two NAND gate, So they have mentioned one cross coupled circuit, and that circuit is realized by using NAND gate. So we can realize either by using NOR gate or by using NAND gate. So they have mentioned NAND gate, okay. So now what exactly they are asking? NAND gate may lead to a oscillation. To NAND gate may lead to a oscillations, okay. So here now we will ask me, sir, how we will get oscillations, in a RS flip flop. So here four options they have provided. Option number A, first you will provide 1 1, then 0 0, now in option number B, first 0 1 then 1 0, then 1 0. Now in option number C, first one is 1 0 then 0 1, then 0 1. Now option number D, here first input is 0 0 then 1 1, then 1 1. Now exactly what examiner are asking, here you will get oscillations. So you will think, sir, how you will get? So just think about that. Think about this question and tell me the answer, which can be the possible answer. Then we will continue the discussing the question, okay. Just tell me which can be the answer, just tell me. Okay, I am waiting for your answer. Can you think in this question? Very good problem, and this is previous year gate problem from computer science branch, okay. This is very good problem. So you can see here which of the following input sequence. So here two input sequence only they have provided. You cannot change multiple times input, only two input sequence. First you can provide this, then this, first you can provide this, then this, first you can provide this, then this, first you can provide and then 1 1. and you will get oscillations, continuous you will get oscillations for every clock, you will get oscillations. So here they have mentioned a cross coupled RS flip flop relies with a 2 NAND gate. So here a 2 NAND gate by using NAND gate, by using, this is one NAND gate and this is another NAND gate. So by using 2 NAND gate, so this is cross coupled connection is here, this is cross coupled connection is here. Okay, now this is your 2 NAND gate cross coupled connection, this is 2 NAND gate cross coupled connection, and here one clock is also connected, one clock is also connected. So if you will apply here one clock, can I write here one AND gate, can I write here one AND gate, and this is the clock, this is the clock, here this is, you can say, clock. One input you can assume R and another input you can assume S, or SR, anyone you can assume, anyone you can assume here. Okay, so you don't assume here this will be a NAND gate, this will be a NAND gate, no, this will be a NAND gate. So now if you can see here, now if you can see here, anyone you can assume output. Suppose you are saying this is Q and this will be a Q bar, this will be a Q bar. So first circuit you have to assume here. So one answer I received here, that is a C, that is third option. Okay, now one answer, anybody can else? So now you can see here how you can get oscillations. If you can see the table of RS flip flop in general, either it can be active low category, either it can be active high category. It will depend on the by which you are creating, but you will get 4 output. At 0 0 or 1 1 you will get no change and invalid. At 0 1 1 will be set and 1 0 1 will be reset. So 4 state exactly you will get. So means 4 state you will get, and in invalid state means both the output are same, but you are not getting toggle. So how you will get toggle here? So sir, how we can get toggle here? How it can be possible if I am providing here first one input, then second input, and every time this will be toggle. How it can be possible? How it can be possible? So now come to the question. What we can do here? Suppose for example, if here input is 1 1, if this input is 1 1, this is 1 1. If this is 1 1, if this is 1 1, then what will be the output? If the input is 1 1, then what will be the output? If input is 1 1, then what will be the output? If here this both input are 1 1, so you will get here 1 1. This is Q into 1, this is Q bar, so you will get here Q bar. Again you will get here Q, means no change, no change. If you will apply here 1 1, so for first option, for this 1 1 you will get no change, you will get a no change. Okay, no change. Then suddenly you will do here 0 0. Then suddenly you will do here 0 0. Then what will happen? Suppose for example this is no change, this is Q bar. It can be 1 or it can be 0. Now if you will apply here 0 and if you will provide the clock, you are getting here 0 0. You are getting here 0 0. And if here this is 0 0, then what will happen? If here this is 0 0, then what will happen? If here this is 0 0, what will happen? If here this is 0 0, then what will happen? Then what will happen? So if here this is 0 0, so 0 dot anything 0, 0 bar is 1, this is 1, and here 0 dot anything 0 bar is 1. So these both are 1 1. According to our assumption, what is our requirement? Both outputs should be complemented, but this is our assumption. But if you will give 0 0 in the circuit, you will get this output. So you are getting here 1 1. This will be stable, yes, this will be stable. Always this is 1 and always this is 1. So in this case, if you are going to apply 1 1 and then you are going to apply 0 0, then permanently you will get output 1. So permanently you will get output 1. Permanently you will get output 1. Okay, just we are considering output as Q. Now, so here you are not getting oscillations. Now come to the second question. If you will apply 0 1. If you will apply, suppose this is 0, this is 1, this is 0, this is 1. So what you will get? What exactly you will get here? What you will get? If any input is 0, output will be definitely 0. If this is 1 and if you will apply clock, so you are getting here 1. So this is 0 and this is 1. So which you have to operate first? This 0 dot anything 0, 0 bar is 1, this is 1. This is 1 dot 1, 1 bar is 0. Now 0 dot 0, 0 bar is 1. Then 1 dot 1, 1 bar is 0. You are getting here output permanently 1. So in this case you are getting output permanently 1. then suddenly you will change the input, and if this is 1 and if this is 0, then what will happen? This will be 1 and this will be 0, and if this is 1, this is 0, then what will happen? If this is 0, 0 dot anything 0 bar, you are getting here 1, you are getting here 1 dot 1, 1 bar, you will get here 0. So permanently this is 0 and permanently this is 1. So here output you are getting 0, because this is a one set condition, one reset condition. So you are getting 1 0. Similarly here, if you will apply first 1 0, so you will get here 0, and if you will apply this 1 0, you will get here 1. You will get here 1, and this output is for here. So you are not getting oscillations. Now come to the last point, come to the last option. So if I will apply here 0 0, if I will apply here 0 0, this will be 0 0, output will be invalid. Invalid state, but you will get output. Invalid means Q and Q bar is same. It does not mean you will not get output. Invalid output means it does not mean you will not get output. We will get output, but Q and Q bar both will be same. Both will be same. So if this is 0 0, this is 1 and this is 1. Both output you are getting 1 1. Both output you are getting 1 1. Now suddenly if you will change input to 1 1. Now suddenly if you will change this input to 1 1. So in the next clock you will get here 1 1. You will get here 1 1. In the next clock you will get here 1 1, and if this is 1 1, you are getting this is 1 1 dot 1 1 dot 1 1 bar, you will get here 0. You will get here 0. Now you can see same time this one is processed here. This one already, this one is processed here. So 1 dot 1 1 bar is 0. So same time both 0 you will get. Both 0 you will get. So now here you can see when I will apply 1 1, initially this both was 1 1. Initially the both was 1 1. Now if I will apply here 1 1. Here 1 1 you will get when you are providing a clock. Now you can see here 1 1, here 1 1. So both gate will process simultaneously. This is the important point. Both gate will process simultaneously. How? So now this part I am going to remove. This part I am going to remove. So now this was actual circuit. If this input is 1 1 and if this output was initially 1 1. Initially 1 1. So you can see this one will reach to here, at same time this one will reach to here. Now both gate will process simultaneously. This is the important point. Then 1 dot 1 1 bar is 0. So you are getting 0 here, same time, because both gate are same. So 1 dot 1 1 bar is 0. Here you are getting 0. Then again this 0 will reach to here. At same time this 0 will reach to here. Then 1 dot 0 1 dot 0, both are 0 0 bar is 1. Then here you will get 1. In same time here you will get 1. In same time here you will get. Then same process will be repeated. So here you will get 0, here you will get 0, here you will get 1, here you will get 1. If this is the output 1 0 1 0 1 0, or if you are considering this as the output 1 0 1 0 1 0, so you are getting here oscillations. You are getting here oscillations. Now you will ask me, sir, if we have applied first 0 0 and then we are applying 1 1, then we are getting oscillations. So first you have created invalid state. First you have created invalid state. Now you will ask me, sir, then why here the same thing cannot be happened? Because 1 1 you are getting no change, and for 0 0 you are getting only fixed state, that is 1. One more state is required. So if you can use here, one more state is required here. Now you will ask me, sir, can I get the same oscillations by input 0 0 then 0 1, or 0 0 or 1 0, or 0 0 and then 0 0, or 0 0 then 1? Suppose I am going to use these 4 options. Here examiner have provided 0 0 only this one, 0 0 1 1. Suppose if examiner will provide you these 4 options, then which can be the correct, or multiple answer can be correct here? Multiple answer can be correct here. So what I am exactly doing here? Process. You have to think here process. By using, the question is, you can remember this theory by using RS flip-flop. Either it can be active low category or active high category, it can be anything. Okay, just we have assumed here active low category. Here we have assumed active low category because clearly examiner mentioned the cross coupled NAND gate. The cross coupled NAND gate. Okay, if examiner will provide only RS flip flop, we can assume active high. So if the question was active high, the answer can be 1 1 and 0 0. So what exactly we are doing here? First, I am going to create a unstable state, or you can say invalid state. First, I am going to create here invalid state. First, I am going to create here invalid state. Okay, so if you will create invalid state, both the output will be 1 1. Both the output will be 1 1. It means this both second input will be 1 1. So if both the second input are 1 1, so second input will decide what will be the output. Second input will decide what will be the output. What will be the output? If any one from this second input is 0, if any one are second input from 0, then output will be fixed. So that will be depend on the second input. So here just you can see these 4 options I am going to process. So initially you have apply 0 0 0 0 0 0 0 0. Okay, so if you will apply 0 0, what output you are getting exactly? We are getting here 1 and 1, 1 and 1. So if you are applying here 0 0, so you will get here 1 1. It will not depend on the second input. Or if you are going to use 1.0 0 0 bar is 1, 1.0 0 bar is 1. Now same time you are applying, suppose first example I am going to use, this is 0 and this is 1, this is 0, this is 1. So if this is 1 1, so here this value was fixed 1 1. Now next input you have applied here 0 and this is 1 at same time, then what will happen? So if this is 0.1, this will process and this will process. So you can see here this is 1.1, 1 bar is 0, so this will be 0, this will be 0, and here this is 0.1, this is 0 bar is 1. So here you are getting 1 and here you are getting 0. So you are getting a valid state at output. If this is Q and if this is Q bar, then what will happen? This is 1 and this is 0. So always you will get a valid state now. Now you can process. If this is 0, if this is 1, so this will be 1 and this is 0 and this is 0. Then what will happen? This is 0.0, 0 bar is 1, this is permanently 1, and this is 1.1, 1 bar is 0. So this is permanently 1 and this is permanently 0. So in this case, if you are applying for 0 0, then 0 1. So output is your permanently. So your output is permanently 1. Now the second case if I am going to consider, again if initial state is 0 0, so this output will be 1 1. If this output will be 1 1, these both are 1 1. Now suddenly you are applying here 1 0. So now if you are applying here 1 and if you are applying here 0, so if here 1 and if here this is 0, then what will happen? This 1.1, 1 bar you are getting here 0, then 1.0, this is 0 bar, you are getting here 1. So now you are getting a valid state. If you will get any valid state at output, so always you will get a valid state. So if this is 0, so this 0 will come to here, and now this is 1, this 1 will come to here. 1.1, 1 bar is again 0 and this is 0.0, 0 bar is 1. So permanently this is 0 and 1, you are getting a valid state. So again in this case permanently output is 0, you are not getting toggle. Now infinite number of clock if you will provide, always output is 0. Initially that was 1, then 0, then 0, then 0, then 0. Now 0 0, then 0 0. What will happen? If initially this is 0 0 and if this is initially 1 and 1, so here you will get 1 and 1. Then if you will apply 0 0, here you will get 0, here you will get 0. So 0.1, this is 0 bar, you are getting 1. 0.1, this is 0 bar, you are getting 1. So again this 1 and 1, then 0.1, 0 bar is 1. So always this is 1 and always this is 1. So both are same. You are getting invalid output, but you are getting constant fixed output, that is 1. So in this case again you are getting 1, but Q and Q bar both you are getting 1. If I am going to write this is Q and this is Q bar, so if this is 1, this is 0, if this is 0, this is 1, but here both output you are getting same, Q and Q bar, but output is not going to be toggle. Now come to the last point. So already we have discussed, if initially this is 0 0, so this is 1 1, If initially this is 0, 0, this output will be 1, 1. So this one will raise to here, this one will raise to here. Now if you will change this 1 and 1. Now if you will change this 1 and 1, then what will happen? Then what will happen? So this one will come to here and this one will come to here. So now same time both will process. This is 1.1, 1 bar is 0. So this will be 0, 1.1, 1 bar, this will be 0. Now this 0 will come to here and now this 0 will come to here. Then 1.0, 0 bar is 1, you will get here 1. 1.0, 0 bar is 1, you will get 1 here. Then similarly here you will get again 1 and this one will reach to here. Again you will get 1.1, 1 bar is 0, 1.1, 1 bar is 0. So you are getting here toggle, 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 toggle. So here you will get output, here you will get output toggle. Here you will get output toggle and Q bar is same and this is also toggle. Toggle. Here Q is equal to Q bar. Here Q and Q bar is same. And in this case also Q is equal to Q bar. Q is equal to Q bar. But if you want to create a sinusoidal, or you can say not exactly square wave, if you want here oscillations at output, so by using this cross coupled NAND gate, or you can say by using RS flip-flop, we can also implement. So what is the theory behind this? First we are going to create invalid state, means Q and Q bar is same. Then we are applying the input for no change. So first you are applying here at 0, 0, at 0, 0, at 0, 0, what exactly you are getting? We are getting a invalid state. We are getting a invalid. Then we are applying here. First you are applying 0, 0. So in 0, 0 you are getting invalid. And in 1, 1, in generally you get no change. But when you will get no change? When previous output was valid state. This is the important point. So if in any flip-flop, if we will apply the input for the no change output, so when you will get no change, if your previous state was the valid state, so if this was 0 and this was 1, and if you will apply here 1, 1, then you will get no change. You can see here, suppose for example, if you can see here, if previous state was, suppose this was 0, this was 1, suppose, so this is 0 and this is 1, Now if you are applying here 1 and 1, then you will not get here toggle state, you will get valid state. You can see 1.1, 1 bar is 0, 0.1, 0 bar is 1, you are getting no change, But if this previous state was 1, 1, and if you are applying the input for no change, you will get a here toggling, you will get a here oscillation. This is the important point. So first we are creating invalid state. Then we are applying the no change input. For a no change. So examiner can you ask here question either by using NOR gate or by using NAND gate, by using any one. Examiner can ask you the question. Okay, now if suppose same question I am going to ask you for cross coupled NOR gate. If same question I am going to ask you by using cross coupled NOR gate. So can you design oscillation by using cross coupled NOR gate? This is my question. Okay, it can be latch or flip flop. Okay, so can you design oscillations by using cross coupled NOR gate? This is my question. So just I am going to change the question and you have to tell me the output. I am not going to provide you the options. Okay, so another question. I hope this question definitely will be clear to all of you. If anybody have any doubt, just ask me. If anybody have any doubt, just ask me. If anybody have any doubt here, just ask me. If anybody have any doubt in this question, we can create. So just you can see here what exactly we are doing. First we are creating here Q and Q bar same. It can be either 0, 0 or 1. It can be anything. It is not necessary both are 1, 1. Initially both can be 0, 0 also. But by using NAND gate you cannot create both can be 0, 0. By using NAND gate easily you can create both output can be 0, 0. Because if any input is 0, both output can be 1, 1. If any input is 0, then output will be 1. Here if any input is 0, then output is 1. It will not depend on the second input. So in NAND gate, easily first you can create both output is 1 1, and then you can change to 0 0, then you can change to 1 1, then you can change to 0 0. But by using NOR gate, how we can implement? By using NOR gate, how we can implement oscillation? But by using NOR gate, how we can implement oscillation? This is very good question and very good logic. Student will think, sir, how it can be possible? How it can be possible? They are not provided you circuit. First, you have to think here. They have provided RS cross coupled. Sometimes student can use here exactly circuit of flip flop. Here you cannot use exact circuit of flip flop. Okay, because clearly they have mentioned. So sometime. Otherwise, your answer can be 1 1 and 0 0. 1 1 can 0 0. So your two answer can be possible. So theoretically, the concept should be clear. First, we will create invalid state, and then we will apply the input for no change. Okay. Now, another question. If I am going to provide you here, suppose this is NOR gate. I am going to use. Suppose here NOR gate. This is NOR gate, and this is NOR gate, and this is cross coupled. I am not going to use here clock. Okay, just I am going to use as a latch. Okay. Now, so here what I want, suppose if this is Q and if this is Q bar. Okay. Now, so what exactly I want here? And suppose this input is A and B. What I want here? I want here oscillations. At Q. So what input you have to provide it? So for which value of AB? Only one time you can change. Only two input you can apply. For which value of AB? Only two times. Input can be changed. So only two input you can use here. Okay. Oscillations will be at output. Will be at Q. So what you can do? First, you can create any one invalid state. So here invalid state, how easily you can create? If any input is 1 from AB, so you can see here this is AB. If I am going to provide input 1 1 here, if I am going to provide input 1 1, then what will happen? If this is 1, this is 1. What will happen? So if any input is 1, 1 plus anything 1, 1 bar is 0. So this is 0. 1 plus anything is 1, 1 bar is 0. So you are getting output, both output Q and Q bar 0 0 means you are getting invalid, but this will be 0 and 0. Now if I will apply here, suddenly this is 0 and this is 0. So when you are going to apply this 0 0, this 0 will come to here, yes, and this 0 will come to here, and you are getting here 0 0, and now only two input you can apply. Now this will be fixed. And now if you will apply here 0 0, here I can write a Q and Q bar. So Q and Q bar you are getting here you are getting 0 0. Now if you will apply 0 0, then what will happen? So 0 plus 0, 0 bar is 1. Here you are getting 1, and in same time this will process 0 plus 0, 0 bar is 1. Here you are getting 1. Then what will happen? This 1 will come to here, and this 1 will come to here. Both will process simultaneously. Then 1 plus 0, this is 1 bar is 0, and then again this is 0. Then 1 plus 0, 1 bar is 0, again this is 0. So you are getting again oscillations. So always for this 0 0 you are getting here 1 1. And if the input is fixed, and now the input is fixed, then output is this is 0 0, this is 1 1, this is 0 0, and this will continue. So this logic should be very clear. I hope this problem is clear to all of you. If anybody have any doubt in this question, just ask me. If anybody have any doubt in this question, just ask me. If anybody have any doubt in this question, just ask me. If anybody have any doubt? If anybody have any doubt, just ask me. Now I want to discuss some important thing here. Here you are getting, sir, Q and Q bar is same. So the circuit is working or not? Yes, circuit is working. Then why we are saying that is a invalid? Generally, what student call invalid output? So if I will write a truth table for SR flip flop. So what exactly truth table of SR flip flop, and what is the meaning of SR flip flop? And what is the meaning of SR flip flop? Okay, so I hope this thing is clear to all of you. Okay, now examiner can also provide you, this is a circuit of exactly SR positive or negative. Okay, so one can be when you are assuming negative level logic, or one you can assume positive level logic. So two questions can be created, so two answer can be possible. First will be invalid state and second will be no change. Always answer will be same. So either invalid sometime you can create by 1 1, and in some time you can create by 0 0. This will be depend on the circuit. If your previous circuit was this is the your, you can say, active high SR flip flop, or you can say this is SR latch. This is active high category of SR latch. And NAND gate, cross coupled NAND gate, you can say this is active low category of SR latch. Active low category of SR latch. Okay, but if you will design active high category of SR latch by using NAND gate, so this same answer you should get 1 1 then 0 0, 1 1 then 0 0. First 1 1 then 0 0. Okay, so now suppose if I am going to write truth table for SR flip flop, always we will write truth table for active high category. So now if this is next state, can I write Qn plus 1? If this is 0 0, if this is 0 1, if this is 1 0, and if this is 1 1. So when set and reset both are 0 0, nothing will happen. You are getting here no change. This is no change. This is no change. This is no change. When you are doing 0 1, you can see reset is 1. So this is reset. Reset, and can I say reset means 0. For 1 0, here this set is 1. So you can say here set, and set means the next state is 1. Now 1 1. 1 1, generally what we will write here, we will write invalid. And what, how we can represent this cross? Don't care. What is the meaning of don't care? So don't care meaning is here in SR flip flop, for example, if I am going to write a SR flip flop, suppose this is S and suppose this is R, suppose this is S triggered SR flip flop, or it can be level triggered. Okay, this is your choice. So this is your clock, this is your Q, and this is Q bar. So now if I will apply here, S is equal to 1 and R is equal to 1. So what will be the output? Output will be don't care. Don't care means output can be 0 or output can be 1. No. Output can be 0 or output cannot be 1. No, you cannot write like this. What do you mean by this invalid? It means this is an invalid input. So here next state, in next state you are mentioning this input you cannot apply. This input cannot be applied. This input cannot be applied in SR flip flop. But if you will apply, then what will happen? Yes, you can apply, and if you will apply, then Q and Q bar will be same. It does not mean circuit will not work, or it does not mean circuit will get any, circuit can get any output. No, output will be fixed. Output will be fixed, but Q and Q bar will be same. Q and Q bar will be same. And we have designed flip flop. The flip flop can provide you both the output. both the output means one is in normal form and one is in complemented form. So this meaning should be very much clear. This meaning should be very much clear to you. So this invalid, or this you are going to write don't care, it means in this circuit this 1 1 input you cannot provide. This 1 1 input you cannot apply. But if you will apply 1 1, so you will get the output. So here Q and Q bar will be same and Q bar will be Q. Both will be same. So in this case, in another word, you can write here this Q is equal to Q bar. But you can apply. So if you want, suppose Q and Q bar same, then what you have to do? You have to apply both the input 1 1. This is for active high category. For active low category, you have to apply 0 0. This concept should be clear. It does not mean You cannot apply both the input. Only we can apply, but in that case Q and Q bar will be same. What is the advantage of this? By using this, here you can create oscillations. So if you want to create oscillations in the output, you can go with this, you can go with this. So sometime in the real world, or you can say in real life, we can use the same thing, we can use the same thing, we can use the same thing. This is a good concept. Okay, and now meaning of don't care should be clear to you. Now the next problem. Now the next problem I am going to take here. Now the next problem. Okay, now the next problem. One more important thing I want to discuss here. One more important thing I want to discuss here with you. Suppose one more concepts I want to discuss here. One more concepts. Okay. Now, and this concept definitely will be more useful in many number of questions. Now, suppose for example, we have one flip flop. Suppose I am going to use JK flip flop, and this is your S triggered JK flip flop. This is your clock, and here this is input J and K. This is here input J and K. Now here we can use this is preset. This is preset. This is active low category. And here we can use this is clear. Either you can write preset or clear, but this is your choice, but this is active low category. Here this is clear and here this is preset. Okay, now here this is output Q and Q bar, Q and Q bar, Q and Q bar. Okay, Q and Q bar. Now my question here, here this circuit will be preset. If this is 0, if I am going to write, suppose this is preset and this is clear. Suppose for example this is clear. Okay, in this case, what will be Q and what will be Q bar? What will be Q and what will be Q bar? So if preset is 0, clear is 0, then what will happen? If preset is 0 and clear is 0, means you are doing preset as well as clear. How both can be possible? So both cannot be possible. So you can say here invalid, or you can say this input cannot be possible. This not possible. So you cannot give this combination you cannot provide. So this is not possible. Not possible. It means in any situation preset and clear both cannot be 0 0. Now if preset is 0 and clear is 1, it means this is active low category. So output is going to be preset. Preset means set. So Q will be 1 and Q bar will be 0. Now if you are doing this is 1 and this is 0, it means clear is operating. So clear means this Q is 0, then Q bar will be 1. So now you can say this is nothing but preset, or you can say set, and here you can say this is clear. You can say this is clear. Now for 1 1, if both are 1 1, so if both are 1 1 means preset and clear are not operating. So output will, this is a normal flip flop operation. This is a normal flip flop operation. Okay, now I want to discuss one important concept here. Now I want to discuss one important concept here. Okay, now suppose for example, when we are applying the input at flip flop, and after some delay, because flip flop, inside the flip flop definitely we will have some logic gates, and all the logic gates will have some propagation delay. So if a propagation delay from input to output for this flip flop is, suppose I am going to assume 2 nanosecond. Suppose for example propagation delay of flip flop means from here to here, means from here to output, this propagation delay from input to output, suppose I am going to assume here 2 nanosecond. I assume 2 nanosecond. Okay, now again preset and clear is also operating. If you will process preset or clear, so suppose when this point is triggered, definitely after some delay the output will process. Yes. So if I will ask you preset or clear, I can write preset or clear delay. Okay, delay is equal to, suppose for example 3 nanosecond. Suppose just I assume 3 nanosecond. Okay, means when you are applying to suppose clear this flip flop, so after 3 nanosecond output will be clear. Now, if I will apply here input, after 2 nanosecond, according to this input, we will get output. According to this input, we will get output. We will get output. According to input, we will get output. Now, one question I am going to provide you, and you have to tell me what will be the output. What will be the output of this flip flop? What will be the output of flip flop? So now, if I am going to provide you here one question I am going to provide, one problem just here to note down for this. For this, if suppose this is J and this is K, if suppose this is J and this is K, if this is J and if this is K. Now, if both the inputs are, suppose for example 1 and this is your clock, this is your clock. Now, initial, this is Q and this is Q bar. Initial state of Q was 1 and Q bar was 0. Initial state of Q and Q bar was 1 and 0. And now you are applying here 1 1. And now you are providing a clock. Then after 2 nanosecond output you will get, and according to 1 1 output will be toggle, because this is S triggered. So here there will be no race around condition. So if this is 1 1, output will be toggle. So output will be 0 and this will be 1. Okay. Now here same time if this is preset and if this is clear, okay. Now if this is clear, now if I am doing here preset is equal to 0, if clear is 1 and preset is 0, so just I am going to write here this is J, here this is K, J and K, here this is preset, here this is clear, and here this is Qn, okay, here this is Qn. And now what you have to find out? Qn plus 1, okay. So J and K is given 1 and 1, preset is 0, clear is 1, and initial state was 1. So what will be the Qn plus 1, and after how much time? So from this preset clear to output, this delay is 3 nanosecond, and this JK to output, this delay is 2 nanosecond. In generally, this delay will be more and this delay will be less. But just I assumed here opposite. Okay. Okay, because this is my choice, I can assume anything. In generally, this can be more and this can be less, but here I assume this is less and this is more. Now I want to ask you, what will be the output? Initially this was 1. Then after how much second it will be modified? Think and give me the answer. Just think here and give me the answer. Then how much second? After how much second this output will be changed? And what will be the output? So here you can say this preset is operating. Here preset is operating. Okay, and here according to 1 1 the output will be toggle. So if this will process, output will be toggle 1 to 0. After how much second? After 2 seconds. And if this will process, so after 3 nanosecond, output will be again 1 to 1. So output will not be going to modified. Output is not going to be modified. And one more case I am going to assume. Here second case. Here one more second case. If J is 1, K is 1, this preset is 0 and clear is 1. If Qn is 0, so initially this was 0. Then after how much second the output will be changed? So these two output we have to find out. And if you are comfortable in flip-flop and if you know the basics of flip-flop, definitely you can give me the answer. I am waiting for your answer, then only I can process. I am waiting for your answer. Tell me what you can think here. This is most important concept. I will discuss here what is the exactly meaning of preset and clear, because definitely, okay, my feelings are saying now in this year examiner can target exactly this preset and clear point. Already in counter we will use. But in counter, you will not apply any external input. You will not apply any external input in generally, that are always generally fixed, and generally they will not target the propagation delay. So anybody can tell me what can be the output here? What can be the output here? Anybody can tell me what can be the output here? Just tell me what you can feel. This is very, if one will process, output will be toggle. If preset will be process, output will be 1. Output will be 1. Now, so you can see here, if you will assume, sir, this preset is processing, so 100% preset will process. So after 3 nanoseconds, this will be 1. So this 1, then after 3 nanoseconds. So can I write here? Again, this is 1 after 3 nanoseconds. Now you will say me, sir, if this is 1 1, so flip flop will also operate according to this 1 1. Flip flop will also operate according to this 1 1. No, this is the important point here. You cannot say, sir, after 2 nanosecond this will be 0, then again after 3 nanosecond this will be 1. No, no. So here the important point, this truth table should be very much clear. Here you can write, complete the truth table. If here this is j and k, here this is j and k. So here j and k can be anything. Here j and k can be anything. So one thing you should remember, if preset and clear are operating, then input can be anything. The flip flop will leave the input. Flip flop will not provide you the output according to the input. So if preset and clear are operating, flip flop will left or will leave the input. So input can be anything. So input cannot decide the output. If preset or clear, any one are operating, so input cannot decide the output. This is the very, very important thing. So here input can be anything. For this 0 1, here input can be anything. Here this is not possible. So these two are not possible. So here input can be anything. Okay, so again here input can be anything, here input can be anything. So for 1 1, input can be anything. Now according to input, now here you will get a output. So input can be anything. If this is 0 0, so according to this you will get output, because both are not operating. According to 0 1 you will get output, according to 1 0 you will get output, according to 1 1 you will get output. But here if preset are working, input will not decide the output. If clear are working, input will not decide the output. Input will not decide the output. Similarly, come to the second point. If initially this was 0, and this was 1, then what will happen? So again according to input, here preset and clear are working, here so preset are working, so input will be left here, input will not decide the output. So input can be anything. If preset are working, so output will be preset, After how much time? So delay of this. So here preset delay is 3 nanosecond. So after 3 nanosecond, again this will be 1. So after 3 nanosecond, this will be modified. This is the important point. So one thing you should remember, if preset and clear are operating, anyone in one time, one will operate or both will not operate. Both can operate simultaneously. This cannot be possible. So either preset will operate, either clear will operate, or both will not operate. So a preset, either preset or clear is operating, in that situation input can be anything. This is the important point. Input can be anything. This is very, very important point. Okay, so this table should be very much clear. In generally, student will study this. No, but here according to input, what can be the output? This is the important thing. So here input can be anything. Here it is better you can write this input can be either 0 0 or 0 1 or 1 0 or 1. Here 4 choice can be possible. So according to this you will get output. According to this you will get output. According to if this is 0 0, so output will be no change. If 0 1, output will be 0. If 1 0, output will be 1, and if 1 1, output will be QN bar. So you will get like this kind of output. And in this case, input can be anything. This case cannot be possible. You cannot apply both preset and clear. And in this case, this can be anything. It will not reflect at the output. I hope this concept is clear to you. Okay, that's why I assume here this is 2 nanosecond, this is 3 nanosecond, because sometime what a student can think, sir, after 2 nanosecond this will toggle, then after 3 nanosecond according to preset this will preset. No, this will not be happen here. This will not be happen here. This is very important concept. Now I am going with some good question from the previous year. Okay, I hope this flip flop concept is clear to you. So two concepts I have discussed here. What is exactly meaning of preset and clear, and how we can create oscillations. How we can create oscillations by using a one cross coupled either NOR latch you can say, or flip flop you can say, or NAND latch you can say, or NAND flip flop you can say. Okay, now the next question I am going to consider. Okay, next question I am going to take from here. Okay, now next question I am going to okay, just note down next question. Okay, if anybody have any doubt in the previous concept, just ask me. Okay, so okay, one question I am going to take from here. Just note down first problem. So you can see here, one flip flop is given. This is not flip flop, this is a counter, complete counter is given, and this is 3-bit synchronous counter. This is a 3-bit synchronous counter is given. Okay, now, and here this is clock. Here this is clock. And now this is 3-bit. It means 3 output, 1 output, 2 output, and 3 output. 3 output is given here. This one is Q0, this one is Q1, and this one is Q2. Q2 is MSB and Q0 is LSB. This Q2 is MSB and Q0 is LSB. Okay, now here one this point is given. This is reset. Sometime examiner can also write reset. They can also write reset bar. They can write reset. This is examiner's choice. But if here this is bubble, this is active low category up. So when this is 0, this will be reset. Reset means clear. And when this is 1, this will not be going to be reset. Okay, now. And now here one gate is connected, and this gate is like this. This is NAND gate, and some input are also complemented. This is first input, this is second input, and third input is complemented, and third input is connected to Q0. Second input is connected to Q1, and third input is connected to Q2. So this circuit is given. Okay, just note down. Now here the question, for the circuit shown in the figure, the delay of the bubble NAND gate is 2 nanosecond. Here this gate delay is given. This is 2 nanosecond. So delay of this gate is, this propagation delay is equal to 2 nanosecond. So propagation delay of this gate is given 2 nanosecond, and that the counter is assumed to be 0 delay, and this counter delay is, propagation delay of this counter, propagation delay is equal to 0 nanosecond. So this we are going to assume 0 nanosecond. So here there is no delay. So now if the clock frequency is 1 gigahertz, and here this clock frequency is given 1 gigahertz, this clock frequency is 1 gigahertz, then the counter behaves as, the counter is, so 4 options they have provided. Mod 5 counter, this is mod 5 counter. Second option is mod 6 counter, and then mod 7, and then mod 8. This is very basic question. This is mod 8. 4 options they have provided. Just note down the question. This is very basic but very good question. Okay, so here delay of this gate is given. Now the important point is, you have to think first, sir, this is a up counter or this is a down counter. So now the question will be arises here. Here in the question they have not mentioned this up counter or down counter. I am going to read exact question. For the circuit shown in the figure, the delay of the bubble NAND gate is 2 nanosecond and that of the counter is assumed to be 0. If the clock frequency is 1 gigahertz, then the counter behaves as a mod 5 counter, mod 6 counter, mod 7 counter and mod 8 counter. Mod 7 counter and mod 8 counter. Okay, so anybody can tell me, sir, this is a up counter or down counter. What this can be? Anybody can guess. So after one time you can consider up and one time you can consider down. Okay, so that you can solve. But no, here if you are expert, you can think, sir, this is up counter or down counter. Anybody can tell me this will be up counter or this will be down counter. Clearly they mention synchronous counter. This is a synchronous counter. Okay, synchronous counter. But this is a up counter or down counter. How you can think? How you can think? How you can think this is a up counter and down counter? One standard protocol you can follow. If we are doing reset, means if we are doing clear the flip flop, if we are doing clear the flip flop at the state 0 0 0 0 0 0, so that can be maximum possibility, that can be here maximum possibility, that can be upper counter. 99.99% times you can assume that can be a upper counter, because up counter generally will start from 0 0 0 and down counter will generally start from 1 1 1. So one concept should be clear. Up counter will generally starts from 0 0 0, and similarly down counter will generally start from 1 1 1. So if you want to restart at any point, if this is not a complete counter, if this is a mod n counter and n is not exactly 2 raised to power n, then what you have to do? You have to do clear or reset, or you have to do preset, or you have to do preset or set. You have to do preset or set. So generally up counter is connected to, so up counter is connected to reset or clear, both are same, and down counter are generally connected to, this is connected to preset or you can say set. And in generally preset is represented upper side and clear or reset is represented downside generally. So by using this basic concept you can think, sir, this counter is a up or down. Here examiner not mention this is standard up or standard down. So if examiner will not provide you up or down counter, so always you have to assume either it can be up or it can be down. So if this is connected with reset or clear, it will be a up counter, and if this is connected with a preset or set, this will be a down counter, if examiner will not provide you. Okay, in this question they are not provided. So you have to first find out that thing. First you have to find out this thing. Yeah, okay. Now good morning everyone. Yeah, good morning. Okay, so first you have to think this is a up counter or this is a down counter. This will be standard up or standard. If examiner will not provided you, always you have to think this is 3-bit synchronous counter. Okay, 3-bit synchronous counter, but this is a connected with reset, it means this is a up counter, standard up counter. So what you can assume is standard up counter. So now you can see this is Q2, this is Q1, this is Q0. So initial, always you have to start initial from 0 0 0. Suppose this was initially reset 0 0 0, then we are applying first clock and this is clock 1, and when you are applying clock 1, then what will happen? 0 0 1. So which will be 0? Initially you can see here this is 0 0 0, then this is 0, this is 0, this is 1, then what will happen? This is 1, this is 0 0, this is 0 0. So when this will be 0, this will be reset for 0, 0 means here you will get 1, when you will get 1, when this is 1 and this is 0. So in this case you will get a reset. In this case you will get reset. Now when you are applying first clock, you will get output 0, 0, 1. Right now I am assuming there are no delay, then I will consider the delay. So when you will apply 0, 0, 1, okay, first clock, so you will get 0, 0, 1. It means 0, 0, 1. It means this is 0, this is not 1. Then you will apply 0, 1, 0. Again this will be not work. So when you are applying clock 2, this is 0, 1, 0. Then clock 3. Then clock 3 will apply 0, 1, 1. 0, 1, 1. Again this is 0, this is 1, this is 1. Not same. Now again you will apply, this is 0, 1, 1. Now fourth clock you will apply here, this is 0, 1, 1, this is 1, this is 0, this is 0. So this is 1, but this is 0 and this is 0. This is not same. So again when you are applying, this is 1, 0, 0. Then the fifth clock. Then the fifth clock. When you are applying fifth clock, what will happen? This is 1, 0, 1. So this is your 1, this is 0, this is 1. Again these are not same. So again this will be not a reset. When you are applying a 6th clock, 6th clock means this is 1, this is 1, this is 0. Now this is 1, this is 1 and this is 0. Now same. So when you are applying 6th clock, 1, 1, 0. So when you are applying 6th clock, so 6th clock when you are applying, this will be reset to 0, 0, 0. This will be reset to 0, 0, 0. This will be reset to 0, 0. But how much delay of this logic get? How much delay of this logic get? Now if I will ask you, this clock is 1 gigahertz. It means this clock frequency is 1 gigahertz. So what is the time period of this clock? So what is the T clock? 1 upon 1 giga. 1 upon 1 giga means 1 nanosecond. So what is the T clock? So T clock time period is 1 nanosecond. So 1 nanosecond. Suppose you are applying clock at 1 nanosecond. Okay. You are going to start initial state. Okay, after 1 nanosecond you are applying first clock. This is at 2nd nanosecond, this is a 3rd nanosecond, this is a 4th nanosecond, this is a 5th nanosecond. Suppose you are applying a 6th nanosecond, then at 6th nanosecond you have applied on 6th clock and you are getting 110 because this delay is 0. Then when you will get here this 0 after 2 nanosecond means 8 nanosecond. But at 7 nanosecond next clock you will provide, because this will provide you output after 2 nanosecond. So at 7 nanosecond, 7 clock already you have provided and you will get output 111. You will get output 111. Okay. So you are getting here output 111 and then 111 will, you will get that output here after again 2 nanosecond. Now, so at 8 nanosecond, 8 clock will be provided. 8 clock will be provided. Yes. So at 8 nanosecond, you will provide here 8th clock. Yes, we will provide 8th clock. And in that case, the output will be 0, 0, 0. But in same time, so now my question is, this output you are getting, this 0, 0, 0 output you are getting because of this clock or because of this reset, because of this reset. So now at 8 nanosecond, this reset, here you will get 0 and here there are no delay of this flip-flop. So when this reset signal is 0, the output will be 0, 0, 0. Now my question is, at 8th clock, you are getting 0, 0, 0. But this 0, 0, 0, you are getting because of this clock or you are getting because of this reset. Anybody can tell me. You are getting 0, 0, 0. But from two cases, you can get 0, 0, 0. You are applying same time clock and same time this reset is operating. But just right now, just already I tell you, you will not get output according to the input, if this reset will operate. So here this 0, 0, 0, we are not getting because of this 8th clock, No, we are getting here. So when you apply 6th clock, then after 2 nanosecond, because of this reset, we will get here 0, 0, 0. Because of this reset, we will get 0, 0, 0. So this 0, 0, 0, we are getting because of a reset. So we are getting because of reset. So how many number of output states you will get here? So you can see here 0 we are getting, 1 you are getting, 2 we are getting, 3 we are getting, 4 we are getting, 5 we are getting, 6 we are getting, 7 we are getting. All 8 states we are getting here. Either you can consider from here, either you can consider this. So total number of output states, how much we are getting? 8 number of states we are getting. So this is nothing but mod 8 upper counter. This is mod 8 upper counter. So this is nothing but mod 8 up counter. So what will be the answer? Answer is option D. Option is answer is option D. Answer is option D. Sometime examiner can also provide you this category of question. They can provide you delay of this logic gate and they can ask you what will be the output, what will be the output, what will be the output. I hope this problem is clear to all of you. If anybody have any doubt in this question, ask me. If anybody have any doubt in this question, just ask me. Now one more modification I am doing here. So in this question, what you have to think first. So first you have to think in this question. First you have to think in this question, this circuit will be up counter or down counter. This circuit will be up counter or down counter. So if this is connected with reset or clear, this will be up counter. If this is connected with preset or set, this will be a down counter. Now the same question, if I am going to change, if delay of this is 1 nanosecond, if propagation delay of this is 1 nanosecond, then what will happen? If propagation delay of this is 1 nanosecond, then what will happen? Then what will happen? So now come to the here till the 6 clock, you will get output 1 1 0, means this is 1, this is 1, this is 0. So when you will get this is 1 1 0, here you will get 1 1 0. So 1 1 0, here you will get a 1, means here you will get a 0, means this reset is going to be processed. But when you will get here 0, here this 0 you will get at 7 nanosecond. So at 7 nanosecond, and at 7 nanosecond you are also providing an X clock. So at 7 nanosecond you are providing a 7 clock, and we are also doing this reset. So which will be practically operated? A reset. So because of this reset exactly, we are getting the output. So at 7 clock, here you will get 1 1 1 1, but you will not get here 1 1 1 if you will apply a 7 clock. So if you will apply 7 clock, output will be 1 1 1, output will be 1 1 1, but you will not get here 1 1 1. This will operate, this reset will operate, and you will not get this 1 1 1. This you will not get, you will get here 0 0 0. You will get here 0 0 0. So how many states here you are getting? 7 states. So this is nothing but mod 7 counter. Mod 7 counter. This is nothing but mod 7 counter. Easily we can handle this category of question. One more important thing, if you have studied, this is a synchronous counter, and in synchronous counter, practically in synchronous counter, this reset button or clear button generally we will not use. In synchronous counter, generally we will use synchronous clear. So this is a specially category of, one kind of synchronous clear. This is specially category of one kind of synchronous clear. This is specially one category of synchronous clear. Okay, but do not go with that. If you know how we can implement mod and counter by using synchronous counter, if you have studied how we can implement mod and counter by using synchronous counter, then totally visualize this question. You can totally visualize. Okay, so right now just you should remember only this. Okay, so if examiner will provide you here delay, so easily you can handle. How you can decide this is up counter or this is down counter? So if this is connected with reset, this is up counter. If this is connected with preset, this is a down counter. Okay, I hope this problem is clear to all of you. If anybody have any doubt in this, ask me. Now I am going to take next question. So till now, most of the question they have asked when they are going to connect with clear. Now the next question I am going to take. Okay, one another problem. And now in this problem I am going to take synchronous clear. Okay, now I hope this problem is clear to all of you. If anybody have any doubt, just ask me. Okay, just note down the next problem. Okay, note down. Next problem is given here. Next problem is given here. Now here you can see 4-bit binary counter is given. This is a 4-bit counter. Okay, this is 4-bit binary counter. This is 4-bit binary counter. This is given. Okay, 4-bit binary counter is given. Okay, now here this is clock. This is edge triggered clock. And here this is one clear. This is clear. So this is clear. So examiner can use either clear or reset. And this is connected with here. This is connected with here NAND gate. This is connected with NAND. This is 4 input 1, 2, 3, and 4. So here total 4 input. Okay, now here 4 output 1. This is 2. This is 3, and this is 4. This is 4 output. Okay, and this output is Q4. Sorry, I can write this is QA. This is QB. This is QC, and this is QD. QA, QB, QC, QD. Okay, now, and here this is connected with QB and QC. This is connected with QC. Just you can remove this, and this is connected with QB. Okay, and here they have mentioned a mod encounter using a synchronous binary up counter. They have mentioned synchronous binary up counter. So they have mentioned this counter is synchronous counter, and this is nothing but binary up counter. They have mentioned binary up counter. Suppose if they will not mention up counter, so we can also assume yes, this is connected with clear. So if examiner will not provide you here up counter, this will be again up counter. So first, by using up counter, you have to solve the problem. If you are not getting answer, then you can assume down counter. But I tell you, in 99% cases, always if this is connected with clear, so this will be up counter. So either examiner will provide you or examiner will not provide you. Okay, and now here again they have mentioned with synchronous clear input, and here this clear is synchronous clear. This is synchronous clear. This is synchronous clear. Okay, this is synchronous clear. What is the meaning of synchronous clear? I will discuss. Just wait for that. And this is a synchronous clear. This is a synchronous clear. Okay. So the mod encounter is, this is a mod encounter. Okay, so n is equal to, you have to find out. So n is equal to, you have to find out. This is a numerical answer type question. Anybody can tell me the answer for this. So one thing they have clearly mentioned, sir, this is a up counter. Yes. And one thing you can also see, they have not mentioned which one is MSB and which one is LSB. So in every question, you have to think something. Examiner want to check your basic concept. If you will assume this MSB, this LSB, because this is connected with QB, QC, and second student will assume this MSB, LSB or LSB, MSB. In both the case, you will get same answer. Because this is connected with QC and QB. So here anyone can be MSB, anyone can be LSB. So either if you are assuming, sir, this is LSB, this is MSB, so again you will get same answer. And if you will assume this as a MSB and this as a LSB, again you will get same answer. That's why examiner have not provided you here which one is MSB and which one is LSB. Okay, now, so if I am going to assume this is QA, this is QB, this is QC, and this is QD. So initially, always you will start from initial. This is 0, 0, 0, 0. Why I am going to start from 0, 0, 0, 0? Because this is connected with clear. If this is connected with a preset, then I will start from 1, 1, 1, 1. And definitely in that situation, that will be a down counter. Okay, so now, when this will be 0, this will be clear. When this will be 0, when this will be 1, both input is 1, 1, means QB and QC is 1, 1. So after first clock, you will get 0, 0, 0, 1. Again, this will not clear. After second clock, 0, 0, 1, 0. After third clock, 0, 0, 1, 1. After fourth clock, this is 0, 1, 0, 0. Now after fifth clock, 0, 1, 0, 1. Now after sixth clock, 0 1 1 0. So at 6 o'clock, so when you are applying 6 o'clock, you are getting output 0 1 1 0. So at 6 o'clock, this is 0 1 1 0, and you are getting here 1 1, and you are getting here 0, you are getting here 0. But this is a synchronous clear. But this is a synchronous clear. It means, what do you mean by synchronous clear? What do you mean by synchronous clear? And they have mentioned here synchronous counter. They have mentioned here synchronous counter. So in general, again I am saying, in 99% cases, if we are using synchronous counter, generally we will use synchronous clear. If we are using synchronous counter, we will use synchronous clear. And if we are using asynchronous counter, generally we will use asynchronous clear. So one thing you should remember, but not 100% true. Again I am saying, this is standard protocol. This is standard protocol. But examiner can ask you question anything. But in a standard protocol, if a synchronous counter, so in a synchronous counter, you can say not if, in synchronous counter, okay. So if you want to design mod n counter, if you want to implement mod n counter, you will not use preset and clear, you will use here synchronous clear. So here synchronous clear or synchronous preset we will use, either synchronous clear or preset. When you will use clear for up counter, when you will use preset for down counter, when you will use synchronous clear or synchronous preset for synchronous counter. And if I can say in asynchronous counter, in asynchronous counter, and if you want to implement mod n counter, here asynchronous clear is used. Asynchronous clear or asynchronous preset are used. This is standard protocol. Okay, so here in this question you can see, this is a synchronous counter and examiner are going to use, this is a synchronous clear. This is a synchronous clear. Now you will ask me, sir, what is the meaning of synchronous clear exactly? What is the meaning of, what is the physical significance of synchronous clear? So just wait for this, I will explain you what is the exact meaning of synchronous clear. Now, so first we will solve this question. So when you will apply the 6 o'clock, so you will get here 0 1 1 0. Now here just we have mentioned this is synchronous clear. So in synchronous clear, this clear button was not we are going to use. We are going to do clear by input, like this, by input. How? So just I want to explain you one basic example. Just I want to explain you one basic example. Just mod 0 1 2 mod 2 counter, sorry, mod 3 counter I am going to explain you. And by using that mod 3 counter, just I am going to use 2-bit counter, and I am going to design mod 3 up counter. Just I am going to design mod 3 up counter, and which category of synchronous, counter. And by using that you can think what will be inside of this circuit. So if examiner will mention this is synchronous counter and this is synchronous clear, what is the exactly circuit of this? So that easily you can take the answer. Right now what generally student will do, here after 6 o'clock you are getting 0 1 1 0, and then in next clock this will be 0 0 0. So in 7th clock, so here in 7th clock, in next clock this will be 0 0 0 0 0. So how many output state you are getting? 0 1 2 3 4 5 6. To total how many states you are getting? This is 0 1 2 3 4 5 6 total. This is a mod 7 counter. 1 2 3 4 5 6 7. So this is a mod 7 counter. So here answer is mod 7. Here answer is mod 7. But what is exactly circuit behind this? What is the exactly circuit behind this? This is the important point. Okay, so now just I want to explain you mod 3 counter. I am going to use only 2-bit counter. Okay, I hope this thing is clear. So this statement should be again clear to you. If generally we are going to use synchronous counter, so in synchronous counter generally we will use synchronous clear, And when we are going to use asynchronous counter, generally we will use asynchronous clear. But both reverse can be used also. But this is standard protocol, and examiner will generally follow these things. Okay, and the reason behind this, why we are going to use this thing, why we are going to use this thing. So just I am going to design here. I hope this thing is clear to all of you. So just I am going to remove this. So here answer is mod 7. So when you are going to when you are getting here 0 1 1 0 means 6, when you are getting here 6, when you are getting here 6, so in next clock when you will apply, output will be clear, output will be clear. So your answer is mod 7. This is mod 7, this is mod 7. Okay, but what is the exactly synchronous clear? Just I want to explain you, and why you are using synchronous clear in synchronous counter. This is the second question. So just I am going to implement mod 3 counter, and this is nothing but which kind of counter? Up counter. And which kind of? This is synchronous counter, synchronous counter, synchronous counter. Okay, by using synchronous and asynchronous, both I will explain. First I am going to explain you by using synchronous counter. So how you can design this, how you can design this, how you can design this. Suppose I am going to use JK flip flop. So suppose I am going to use JK flip flop, JK flip flop. Okay, so JK flip flop here to use. So now, so initially I am going to start. So I want to design from 0 0, then this should be 0 1, then this should be 1 0, then this should be 0 0. This counter I have to design 0 0 0 1 1 0 0 0 0 1 1 0. So how? So here just I am going to write this is present state, this is present state, and this is next state, this is next state. Okay, present state and next state. So present state I am going to use MSB flip flop. Suppose for example this is QA, I am going to use, this is QB, A is MSB, and here this is next state, this is QA plus I am going to write, this is QB plus I am going to write for the next state. So suppose for example initial state is 0 0, then next state is 0 1. If initial state is 0 1, next state is 1 0. If initial state is 1 0, next state is 0 0. If initial state is 1 1, next state will be 0 0. Just you have to implement this, just you have to implement it. So 1 1 will be invalid state, but suppose if anybody are going to start from 1 1, it will reach to 0 0. So you have to implement this circuit, you have to implement this circuit by using which flip flop. Suppose if I am going to design by using JK, suppose, so this is JA, this is KA, or I am going to design by D flip flop. D flip flop will be easier. So just I am going to use here, this is DA and this is DB. So by using, sometime when you are going to implement by D flip flop, the circuit can be complex, more number of logic gate is required. But when you are going to use by JK flip flop, less number of logic gate is required. So excitation table is required here. And if you remember the excitation table, so by using JK you can also design. So I hope, what is excitation table by JK? So if you know, this is Qn and this is Qn plus 1, and what is for JK? JK excitation table, this is for 0 0, this is 0 1, the 1 0 and 1 for 0 0. What is the JK excitation table for 0 0? If you remember this, what is the JK equation? Qn plus 1 is equal to J Qn bar plus K bar Qn. So from this you can also find out this value. So if you can see here, this is Qn plus 1, this is 0, and this Qn is 0, so this Qn bar is 1. So if this should be 0, so K bar definitely should be 0, so K should be 1. So if this should be 0, so this should be 0, so this J should be 0, J should be 0, and here this is 0 multiply anything 0, so K bar can be anything, so K can be anything. This is 0x. So you should remember this is 0x, this is 1x, this is x1, this is x0. You should remember excitation. So I can design by JK flip flop. Okay, so this is JA, first this is KA, this is JB, and this is KB. So this JK value you have to find out. So for A, this is for 0 0. A you have to consider present state is 0, next state is 0, then 0x. So this is 0x. Then this is 0 1. For this 0 1, this is 1x. So this is 1x. Now next, this is this is 0 1. So if this is 0 1, this is 1x, and this is 1 0. This is 1 0, then x1, then x1. Then this is 1 0, and this is 1 0, then again x1. Now the second value, this is for 0 1. This is for 0 1 1x. This is for 1 0. This is for 1 0. This is x1. This is x1. This is for 0 0. This is 0x. this is 0x, and this is for 1 0, this is x1, this is x1. So now you can find out the value. Now you can find out the value. So of JA, KA, JB and KB. So just you can implement. Just I am going to remove this now. So here two stages flip flop is required. Two stages flip flop is required. This is one flip flop and this is second flip flop. Now the important thing in general, MSB, if you will implement asynchronous counter. So when you are going to provide clock, that is LSB flip flop. So in general, in asynchronous counter, this left side was the LSB flip flop, right side was the MSB flip flop. But here this is your choice. In synchronous counter, this is your choice. Your choice. Either you can use this MSB or LSB, or this LSB, this MSB. This is your choice. But in asynchronous counter, generally we represent clock from left side, and when which flip flop you are providing the clock, that flip flop is the LSB flip flop. So now later I will discuss which will be the here LSB and which will be the MSB, like this. So this is your clock. This is your clock. Okay, this is your clock. Which is A and which is V, we will write. So now this is Q and this is Q bar. This is Q and this is Q bar. This is J, this is K, and this is J and this is K. Okay, like this. So now just you have to find out here the value. Here the value you can see here. This KB, all are x1, x1. So can I write this is 1? Yes. What I can write this KA? So KA is again 1. So KA and KB both are 1, 1. Both are 1, 1. So this K is 1. This K is 1 and this K is 1. Both K is 1, 1. What is the J? What is the J? 0, 1, XX. If you will find out JA, if you will find out JA, this is 0, 1, XX. And this is JA. This is J. This is 0, 1. This is 0, 1. And what is this value? This value is nothing but this is QA and this is QB. So which group you can form? Which group you can form? You can form this value. This is 1x. So if you are going to form this group, this is nothing but QB. So JA is nothing but QB. JA is nothing but QB. So can I write here JA is equal to QB? So can I write here? Can I write here? Can I write here JA is equal to QB? Can I write here J is equal to QB? Now the second value 1x 0x. So what is your here? This is JB. What is your here JB? 1x 0x. This is 1x, this is 0x. And this is your QA, this is your QB. This is 0, 1, this is 0, 1. So which group you can form here? This group you can form here. And this value is nothing but QA bar. So JB is equal to, this is nothing but QA bar. So JB is equal to QA bar. So JB is equal to QA bar. So here I am writing JB is equal to QA bar. Okay. I think calculation you can check. Okay. Okay, just I want to discuss the concepts. What is the exactly synchronous clear? So just I want to explain what is the exactly synchronous clear. So if suppose I am going to assume this is JA. So this if B, so JA is equal to QB. And if this is JB, so this is nothing but QA bar. So this like this you have to connect here. Like this you have to connect here. So suppose if I am going to assume, if you will assume this is A, so J is equal to QB. So this will be connected to here. And if you will connect this suppose B, so this QA bar will be connected. So anything you can assume. Just I am going to assume this A. So this is JA, this is KA, this is QA, this is QA bar. And if this is B, this is B, this is B and this is B. You can also assume this A and this B. This is your choice. Both the K are 1. Both the K are 1. Now, JA is nothing but QB. So this JA is connected to QB. And JB is connected to QA bar. So this QA bar is connected to JB. This is the circuit. This is the circuit. Now I will ask you, if this question is given, what will be the number of output states? Reverse question I am going to ask you. So how you can find out? Yes, easily we can handle. This is your QA and this is your QB. So initially both are 0, 0. So just I am going to write, you can say this is QA and QB if initial both are 0 0, so after first clock, second clock, what you will get? So after first clock, if this initially this is 0 and 0, if this is 0, this is 1, so you will get this is 1. If this is 0, this is 1, you are getting here 1. So both input is 1 1. So this is, you can say 1 1 and 1 1. So both will be toggle. Both will be toggle. So I think there are some mistakes we did. I think yes. This mistake, J is nothing but QB. Na? This is connected with QB. So this is connected with QB. Here just you have to correct. Just here this you have to correct. So now if initially this is 0, so here this will be 0. So this is 0 1 and 1 1. So first flip flop output will be 0 and the second flip flop output will be toggle. So this 0 toggle is 1. So you are getting here 0 1. So now you are getting here 0 and you are getting here 1. So you are getting here 1. So when you are applying the second clock, so if this is 1, you are getting here 1. If this is 0, so this is 1. So this is again 1 1 and this is 1. Both will be toggle. So in second clock, both will be toggle. So this 0 toggle is 1, 1 toggle is 0. So you are getting 1 0. In next clock, in third clock, so after second clock, this output is 1 and this output is 0. This output is 0. This output is 0. So if this is 1, this is 0. This is 0. If this is 0, this is 0. So 0 1 and 0 1. So for 0 1 0 1 output is 0 0. So you are getting the same output 0 0 0 1 1 0. So our this circuit is correct. Now so you are getting this circuit for mod 3 up counter, and this is a synchronous counter, and which kind of clear you have used here? This is my question. So my question is how you can represent this like this. Suppose if I will provide you the same question in this way, so what will be the circuit? I hope this thing is clear. Just I am going to remove this. Just I am going to remove this part. Okay. So now if you want to implement mod 3 up counter, which category of synchronous category of which kind of clear? Synchronous clear. Which kind of clear? Synchronous clear. So this is the example. And if you want to apply this box you can write in this way. This is nothing but 2-bit binary up counter. Which category of? Synchronous up counter. This is a synchronous counter. And which category of clear here? Synchronous clear. So this is going to be clear. Yes, this is going to be clear. But we are not going to use here clear button. This is the important point. We are not going to use here this clear button. So you are not going to use here clear or preset. You are not going to use here clear or preset. Clear this point? So now how you can represent? So I will represent here one clock. Here this is 2 output. You can say this is QA and this is QB. So 2 output you are getting. But if you want to represent, this is not a complete counter. So just you will assume, just you can write here 1. This is either you can write reset or you can write clear or reset bar like this. And just you can apply here one NOT gate. This is a representation of this circuit. But this is not a meaning here you are using reset or clear button. No, we are not using here reset or clear button. If examiner will mention synchronous clear, it means we are not using here this reset or you can say this clear. We are not using this. Like this we are going to design the circuit, but representation is like this. So this is very big difference between synchronous clear and asynchronous clear. I hope this problem is clear to all of you now. So if I want to design here, so when this will be clear, so you are getting here 3 states. So if you are getting here 3 states, means 0 0 you are getting, 0 1 you are getting. First you will apply clock. This is 0 0, then 0 1, then 1 0. 1 0 is also you are getting. So this is for 1 1. You will do clear. This is for 1 1. If this is 1 1, so 1.1 1 bar is 0. Then this will be clear. So this will be the circuit. So can I represent like this? This is correct representation. No, again I am going to tell you. So how you can represent this circuit in this way? How you can represent? So you will write first here. This is a synchronous clear. synchronous clear. And for which state you are doing clear, that state you will get. So here if you are doing clear for 0 1 1 0, that state you will get. So which state is required here last? That is 0 1 0 1 0. So this QA is 1 and this is 0. So if this is 0, you can put here one bubble and like this. This is the actual representation. Of synchronous clear mod and counter. So now if examiner will ask you this question, how you can say the answer? Sir, when you will apply, initially this was 0 0, you can write QA QB. This is initial, this is 0 0. When you will apply first clock, this is 0 1. When you will apply second clock, this is 1 0. 1 0 will do here reset or clear? No, you will get 1 0. And then you will apply the next clock, means at third clock you will get 0 0. So this is the representation of synchronous clear kind of circuit. I hope this thing is clear. What is the inside of this circuit? Inside of this circuit is nothing but this one, and this one is represented by this. So if examiner will provide you synchronous clear, suppose for example, so it states which you are getting at output, that state you will get, and in next state you will get a clear or you will get a preset. So in next state you will get. So here this 1 0 state you will receive, and in next state the output will be 0 0, and in next state output will be 0 0. I hope this thing is clear. So what will be the inside of this? Inside of this is the 4-bit up counter, and 4-bit counter, and where you are not going to use clear or reset button. You are not going to use. So last output state is 0 0 1 1 0. 0 1 1 0. But if this is a asynchronous clear, for example, if this is a asynchronous clear, so how you can also design asynchronous clear? How you can also design? So you will design here a standard up counter, and 1 1 is not required. So when you are getting output 1 1, and that 1 1 is connected to this clear, I hope this thing is clear. But in generally, if you are going to use synchronous counter, synchronous clear is used, and if we are going to use asynchronous counter, asynchronous clear is used. I hope this thing is clear. Asynchronous is used. This is the important point. Okay, so in same question, suppose for example, if examiner will provide you this asynchronous clear, suppose for example, so if asynchronous clear, it means this button are using, and already I tell you in today's second question, if this clear are operating, in that situation this clock and input is not required. So if asynchronous clear, when you are going to use this clear, means this is a asynchronous clear, and when you are going to do output 0 0 0 by using input, that is a synchronous clear. So representation should be clear. Examiner if provide you this question, and if they will mention synchronous clear, it means the output state which you are getting, that will be the last output state, and you will get that state. But if examiner will mention this is asynchronous clear, and if examiner will not mention anything, that is understood that will be a asynchronous clear. But in standard protocol, if this is a synchronous counter, so generally we will use synchronous clear. If this is a asynchronous counter, then we will use asynchronous clear. Clear this point? So if anybody have any doubt in this question, just tell me. Now I am going to take one another problem. So what will be the concept behind synchronous clear? What is the concept behind synchronous clear? I hope this thing is clear to you. Here we are not going to use clear button, and in asynchronous clear we will use clear button. Okay, and when you will use clear button, flip flop will not wait for the next clock. Okay, when you are getting when you are using asynchronous clear. But if you are not using asynchronous clear, it means this button is not operating. So every output you will get according to the input. So when you will generate here 1 0, 1 0 is the last state, and then after 1 0, when you will apply the next clock. So it means When you are getting here 1 0, that 1 0 will create next input for the next clock, and that input will create output 0 0, and that input will create output 0 0. I hope this thing is clear. Anybody have any doubt? Okay, no doubt. Now, so next problem I am going to take here. One more problem I am going to consider here. So in every question, what exactly examiner have mentioned, this is very important point. This is very important point. This is very important point. Okay, now this I am going to remove this. Just I am going to remove this. Now the next example. One more example I am going to consider. Next example. Okay, just note down. Here again, just examiner have mentioned one binary counter. Here, this is a binary counter. Now, here, this is the clock. And again, this is clear. Again, active low. This is clear. Okay, now this is active low category. But here they have mentioned one XNOR gate. This is XNOR gate. Okay, XNOR gate. Okay, no worry. Here this is 4 output, 1, 2, 3 and 4. And 4 output is given. This is Q3, this is Q2, this is Q1 and this is Q0. And now this is connected with Q3 and Q2. This is connected with Q2 and Q3. Now I am going to read out the question. The figure shows a binary counter with synchronous clear. This is a binary counter with a synchronous clear. This is a binary counter with a synchronous clear. Okay, synchronous clear input. Now next they are saying with the decoding logic shown, with the decoding logic shown, the counter work ऐसे. Okay, mod 2, mod 4, mod 5, mod 6. This is a multiple choice. This is a mod 2. B option is mod 4. C option is this is a mod 5, and D option is mod 6. So 2, 4, 5, 6. Anybody can give me the answer. I am waiting for your answer. here. Mod 2, mod 4, mod 5 and mod 6. Again they have mentioned here synchronous clear. But in this question they have not mentioned this counter is a synchronous counter or asynchronous. So this is not required. It can be synchronous or asynchronous. But if examiner have mentioned synchronous clear, so again we can assume the counter will be synchronous counter. So definitely this counter will be synchronous counter. Already I tell you, in synchronous counter we will use synchronous clear. In asynchronous counter we will use asynchronous clear. Okay, there are so many reasons behind this. Okay, so if you will attend my theoretical classes, I will tell you. Okay, but right now just I am telling, just you should remember this in general, but there are no required this synchronous counter or asynchronous. But if you want to find out this is a synchronous counter or asynchronous, so this will be a synchronous counter. Now, sir, this is Q3, Q2, so definitely Q3 will be MSB. This is understood. And here Q0 is LSB. Examiner have not provided, but this is basic because 0, 1, 2, 3 they have mentioned. Now, they have not mentioned this is up counter or down counter. They have not mentioned this is a up counter or down counter. So what you will assume? If this is connected with clear, so definitely you will start from up counter. And here this is a multiple choice question. If your answer will not match, then you can think with a down counter. But always first you will start with up counter. So your assumption is up counter. Your assumption will be up counter. Why up counter? Because this is connected with clear. So just I am going to write here. This is Q3, this is Q2, this is Q1, this is Q0. Initial this is 0, 0, 0, 0. If this is initial 0, 0, 0, 0, This is 0, 0, 0, 0. Now when this will clear, when you will get here 0, means when you will get here 1, when you will get here 1, and this is connected with Q3, Q2, Q3, Q2. So Q3, Q2, Q3, Q2, when you will get 1, when both are different, it means after first clock you will get 0, 0, 0, 1, after second clock you will get 0, 0, 1, 0, after third clock you will get 0, 0, 1, 1, after fourth clock you will get 0, 0, 1, 0, 0. So in fourth clock, Q3 and Q2 are different. So if this Q2 is 1 and this Q3 is 0, if this is 0, 0, yes, 0, here we can write this is 0, 1, 0, 0. So this will be clear. This will be clear. So in fourth clock, this is a clock number 1, this is a clock number 2, this is a clock number 3, and this is a clock number 4. So in fourth clock, this will be clear. Now you can see here, this is synchronous clear or asynchronous clear. This is a synchronous clear or asynchronous clear. This is a synchronous clear or asynchronous clear. So 100% this is a synchronous clear. Already they have mentioned this is synchronous clear. So this last state you will get, yes, this state you will get. So initially this is 0, 1, 2, 3, 4 you will get. Now in the next clock, now when this output is 0, 1, 0, 0, and in next clock the result will be 0, 0, 0, 0. The next clock result will be 0, 0, 0, 0. So how many output states you are getting? Total 5 states we are getting. 1, 2, 3, 4, 5. So this is nothing but mod 5 counter. This is nothing but mod 5 counter. This is up counter or down counter. This is up counter. This is mod 5 up counter. So this is mod 5 up counter. This is mod 5 up counter. Okay, easily we can handle this category of question. Easily we can handle this category of question. Easily we can handle this category of question. Now my question. Now if I will give you one question and you have to give me the answer. You have to give me the answer. Okay, now next question, just note down. Next question, just you have to note it down. Now, so just I am going to provide you one counter. Okay, this is a again only binary counter. I am saying this is a binary counter. This is a binary counter, and here this is clock. Here this is clock. Okay, here this is clock. And now this is synchronous counter. This is synchronous counter. This is a synchronous counter. Which kind of counter? This is synchronous counter. Here 4 output. 1, 2, 3, and 4. This is Q3, this is Q2, this is Q1 and Q0. Okay, now here I am going to use this is clear. This is clear. Again, same circuit I am going to use here. If this is a NOR gate, and this is connected with this Q1 and Q2, and this is connected with Q1 and Q2. And here I have not mentioned. This is synchronous clear or asynchronous clear. This is up counter or down counter. I have not mentioned both the thing. What will be the mod n counter here? What will be the mod n counter? What will be the mod n? So n is equal to question mark. Anybody can tell me the answer here. I have not provided you here. I have not provided you here. This is synchronous clear or asynchronous clear, or this is a up counter, or this is a down counter, or which one is the MSB, which one is the LSB. You have to think. So you have to think here, but only one answer is possible here. So if you will get this kind of question in GATE exam, suppose for example, if you will get this kind of question in GATE exam, then how you can handle? How you can handle? How you can handle? I am waiting for your answer. I am waiting for your answer. Just tell me. I am waiting for your answer. Just tell me. I am waiting for your answer. So first you can find out which one is MSB, LSB. So definitely this will be MSB and this will be LSB. Okay, now when this will be clear, when you will get 0 here, this when you will get 1 here, this is XOR gate and 2 input. So if any one is 0, one is 1. If it means, and what you can assume, this is up counter or down counter. This is first assumption. So sir, definitely the result, the output is connected to clear. It means this is up counter. So what should be your assumption? Your assumption should be up counter. This is not mentioned. Up counter, this is assumption. This is assume. This is your assumption. So first you will assume, sir, this is a up counter. So okay, you can write this is Q3, this is Q2, this is Q1, this is Q0. So if this is the up counter, this will start from 0, 0, 0, 0. So after first clock, this is 0, 0, 0, 1. These both are 0, 0. After second clock, this is 0, 0, 1, 0. In second clock, this is if 0, 0, 1, 0. So here you are getting this is 0, and here you are getting, if this is 0, 1, output is 1, this is 0. So this will be clear. So in second clock, this will be clear. Now if this is a asynchronous clear, so you will not get this output. Only two states you are getting 0 and 1. But if this is a synchronous clear, so you will get this 3 output. So what you will assume, in next third clock, this is 0, 0, 0, 0. So you are getting this, it means this is synchronous clear. So here this is first state, second, third. So this is mod 3 counter. This is mod 3 and your assumption is up counter. This is the answer. So answer is mod 3 up counter. What was your second assumption here? My second assumption is here, this is a synchronous clear. Synchronous clear. If examiner will not mention this is synchronous clear or asynchronous clear, what you will assume? This is my question. If examiner will not mention here this is synchronous clear or asynchronous clear, what you will assume? What you will assume? If this is a synchronous counter, you will assume synchronous clear. If this is a asynchronous counter, you will assume asynchronous clear. So if I have mentioned here synchronous counter, so what should be your assumption? Your assumption should be, again this is assume. So you have assumed this is synchronous clear. It means 0, 0, 1, 0 we will get at last state, and then in next clock we will get 0, 0, 0, 0, and in next clock we will get 0, 0, 0, 0. This is mod 3 and your assumption is synchronous clear and your second assumption is up counter, and then you are getting this is mod 3 up counter. This is mod 3 up counter. Suppose if second student, if anyone assume if asynchronous clear, if asynchronous clear, then what will be the answer? Then this is a mod 2 counter. This is a mod 2 counter. So if examiner will provide you this question, so some student will write the answer mod 2 counter, some student will write down answer mod 3 counter. 1% will give here mod 3 counter, 99% will give mod 2 counter, 1% will reach to IIT or in PSU, 99% will reach to NIT, or again they will start the preparation. So first you have to see here what should be your assumption. Sometime examiner cannot provide you each and everything. If examiner will not provide you, you have to assume and you have to think. So if this is a synchronous counter, your assumption should be 100% here synchronous clear. And if multiple choice question and if the option is not given, then you can think with asynchronous clear. But always examiner will provide you here synchronous clear. So if synchronous counter, synchronous clear. If asynchronous counter, asynchronous clear. This concept should be also remembered to you. This concept should be also remembered to you. This concept should be also remembered to you. I hope you can handle this kind of question. So if this is asynchronous clear, asynchronous counter, asynchronous clear, if this is a synchronous counter, so you have to assume synchronous clear. So I hope now easily you can handle this category of question. Okay. So if anybody have any doubt, just ask me. I am waiting for your doubt. I am waiting for your doubt. I am waiting for your doubt. So just ask me if anybody have any doubts. Okay, if anybody have any doubt, just ask me. So today's session, then I am going to stop here. Okay, and tomorrow I will take some more good problem. I will discuss some good problem from setup time and hold time also. Okay, so in next class I will discuss some question from setup time, hold time. Okay, and like this. Okay, from this topic and some more good problem I will also discuss from sequential circuits. Okay, so tomorrow I will discuss another some question from synchronous circuit. I hope now easily you can handle. I hope now easily you can handle. Easily you can handle questions from here. Okay. So anybody have any doubt, just ask me. Okay, no doubt. If anybody have any doubt till now, just ask me. Tomorrow class will be again very important, because setup time, including setup time, I will also discuss the whole time concept. Okay, I will also discuss the whole time concept. Okay, so today's session I am going to stop right now here, and tomorrow at 10 a.m. we will meet. Yeah, signal classes actually we have paused. Just after completion of digital, we will continue the signal classes. Okay, so after completion of digital, we will continue the signal classes. Okay, so tomorrow we will meet at morning 10 a.m. with again some good problem from sequential circuit. Okay, thank you, take care, bye bye, and Jai Hind.